Hello viewers, welcome back to my channel. This is the second video lesson on scalars and vectors. And in this video lesson, we are going to look at the resolution of vectors, specifically the resolution of just two vectors. As in next video lesson, we focus on how to resolve more than two vectors. In this video lesson, we are going to look at an introduction to resolution of vectors, and after which we look at the resolution of two parallel vectors acting in the same direction, and thereafter we look at how to resolve two parallel vectors acting in opposite direction, from which we are going to look at the resolution of two vectors acting perpendicularly, here we mean at 90 degrees to each other, and lastly we look at two vectors that are acting at an angle other than 90 degrees to each other, and lastly we'll look at some practice questions. So we must understand what the term resolution of vectors mean. Now, for scalar quantities, they can be added or subtracted easily. So what do we mean? If we have 5 kg of rice and then we have 2 kg of rice, so in addition, or the sum will give us 7 kg. So we can simply add them up. Or if we have 3 meter minus 2 meter, we can end up having 1 meter. So for scalar quantities, they can be added arithmetically, so you can easily add or subtract them. But for vector quantities, here lies the difference. We cannot add them or subtract them easily because of their directional property. So a good question you could be asked in exam is that, why can vectors not be added arithmetically? That's just adding them 5 plus 2, 7 minus 2, 3 minus 2. Why can't they be added or subtracted in that manner? The singular reason is because of direction. Because if you remember the difference between scalars and vector, you clearly agree with me that scalar quantities are quantities that have magnitude but no direction. But for vector quantities, they have magnitude and direction. So because of their directional property, you cannot just add them or subtract them arithmetically. So when you try to add them, you must take into consideration their direction. So hence, vector quantities cannot be added or subtracted arithmetically. But when you want to add them, you must take into consideration not only their magnitude, but also their direction. So I cannot add something. Let's say we have a force acting on a body, and this force is acting north. Let's say 10 Newton north. And then we have a second force. Let's say 10 Newton acting east. I cannot add both of them. So this is north, and then this is east. So I can't add both of them, and at the end of the day, I will arrive at 20 Newton north. So this is not possible because one is clearly moving north and the other is clearly moving east. You must take into consideration their direction. This is east. I cannot ignore east at the final point of my calculation. So this is totally wrong. So in addition of vectors, their direction is very, very important alongside their magnitude. So what is resolution of vectors? So resolution of vector is simply the addition or the combination of two or more vectors. So we are trying to add these vectors, but in doing so, you must add or subtract them in magnitude 1 and then in direction. And the final vector you are going to have is what is called a resultant vector. So in the exam, you could be told to calculate resultant vector. So resultant vector is simply a combination of the vectors that you have been given. Now, let me give you an example. Let's say we have two forces. Let's say this is a force A, and then we have a second force B. So we have two forces. Now A is acting north. So A is clearly acting north, and then B is clearly acting east. Now the resultant is a combination of these two vectors. Resultant will go in between the two of them in this case. Now this resultant arrow is a combination of both north and east. So at this point, we are going to have what we call northeast. NES stands for northeast. So this resultant is a combination of A and then B. So that's why when we are writing, we are going to write arrow, that's the resultant, in magnitude and in direction is equal to A in magnitude and direction plus B in magnitude and then in direction. So in vector, we are concerned not just about their magnitude, but also their direction. So in this case, arrow is not just bearing north and it's not just bearing east, but it's bearing a combination of both north and east because it must represent these vectors A and B, in this case, in magnitude and also in direction. So that's why we are going to look at how we can add vectors. There are different ways of acting vectors based on how they are moving. Either they are moving in the same direction, in opposite direction, perpendicularly, or at certain angles to one another. So we begin by looking at the relation of vectors that are acting in the same direction. Now, if you look at this vector here, 8 Newton, the vector is acting east, and then we have a second vector here, 10 Newton, also acting eastward. Now, just to make it easier, we have what we call cardinal points. Now, we have 4 major cardinal points. So we have this, we have north, upward. Then at the bottom, we have south. Then towards the right, we have what we call east. Then towards the left, we have what we call west. Now, in between, there exists other directions. So in between here, we have what we call NE, which is northeast, because this point is clearly between north and east. Now, this is clearly between south and west. So you must give preference to your north first or to your south. So that's why we are saying southwest. So we can also have this. Now, this point is clear between southeast. Now, this is clear between north and west. So we'll call this northwest. So these are the various points we have. So now, this is a box. Let's say this is box 1. Box 1. Now, on box 1, there are two forces, 8 Newton acting east, and then 10 Newton also acting east. So just let's say we have a box, and two persons are pulling the box. The first person is pulling with a force of 8 Newton, and then the second person is pulling with a force of 10 Newton. So in essence, we expect this box to move towards the east with this combined force. So at the end of the day, we are going to have this box moving towards the east with a combined force, and the combined force is going to be 10 plus 8. So we have 8 Newton plus 10 Newton, and this will give us 18 Newton. So the box is going to move 18 Newton towards the east. So remember, this is a vector. The magnitude here is 18 Newton, and direction is also towards the east. Now, in this case, we have two forces. In this case, we have 10 Newton, and then we have 7 Newton, and both of them are clearly moving towards the west. So in this case, the combined vector will be 10 Newton plus 7 Newton. So this will give us 17 Newton. And remember, your combined vector is what we call the resultant vector. The resultant vector. And the resultant vector is that single vector that we act in both magnitude and in direction. So we are going to end up having something like this. So this is the box. So we have this box. So we are going to have this. We are going to have 17 Newton. So 17 Newton is a combination of the 10 Newton and the 7 Newton. So it's going to move 17 Newton towards the west, because this is a vector in both magnitude, 17 Newton, and then in direction towards the west. So I hope that's clear. So in this section, we are going to look at a resolution of two vectors acting in opposite direction. So if you look at this first example, we have a force 10 Newton acting towards the east, and then we have a second vector 3 Newton acting towards the west. So they are clearly acting in opposite direction. So just like we have a man on this end dragging this bus or pulling the bus, and then we have a child on this other aspect dragging the bus. Now, we expect this bus to move towards the direction of the man. Why? Because the man is exerting a bigger force. So now take note, when you have two vectors that are acting in opposite direction, you simply subtract the smaller vector from the bigger vector. So one of the things you should notice here is that number one, you simply subtract the vector. So you're simply going to subtract the vectors. And secondly, the vector is going to act in the side of the bigger vector. So the direction is towards the bigger vector. Direction is towards the bigger vector. So take note, these are the two clear things you must have in mind when you see two vectors that are acting in opposite direction. So in this case, this box is going to move like this. So this is the box. Now we are simply going to say 10 Newton minus 3 Newton. So this will give us 7 Newton. So the box will move towards the side of the man with a force of 7 Newton. So it's going to move eastward. So in this case, in magnitude, we have it to be 7 Newton, and then direction we have it to be towards the east. Now take note of this. Now, it's just like we have a man and a child. Now the man, out of this 10 Newton the man has, the man is going to use 3 Newton to overcome the force that this child is exerting. Then what's left for the man is 7 Newton. So the ball is going to move 7 Newton towards the direction of the east, or the bigger vector. So in this case, we have a box, but we have a force pulling it upwards, a force of 20 Newton pulling it towards the north. And at the south, we have a force of 5 Newton pulling it southwest. So in this case, we are simply going to subtract. So we are going to have it as 20 Newton minus 5 Newton, and this will give us 15 Newton. So we expect this box to move like this, 15 Newton towards the north. So 15 Newton northwest. So clearly the arrow already tells us that the force is going to act towards the north. So remember, when you have two vectors acting in opposite direction, you simply subtract the vector. So subtract the smaller vector from the bigger one, and then the direction will be towards the side of the bigger vector. So in addition, when two vectors are acting in the same direction, the angle between them is said to be 0 degree, and also they will exhibit their maximum force in the case of forces, or the maximum state. So they will exhibit what we call the maximum state. So if it is forces, they will exhibit the maximum forces. So let's say we have 10 Newton here, and then we have 3 Newton here. The total will be greater than 10 and 3. In this case, 13 Newton. So you exhibit the maximum. And this can only happen when they are acting in the same direction, or the angle between them is 0 degrees. So in exam, you could be asked, when vectors are acting in the same direction, the angle is said to be 0 degree. Now, when we have two parallel vectors acting in opposite direction, the angle between them, first of all, is 180 degree, and we exhibit their lowest or their minimum state. So they exhibit something lower than what their sum should give us. So if we have 10 Newton and then we have 3 Newton, we expect the sum to give us 13 Newton. But in this case, remember, we are going to subtract. So we are going to have 10 minus 3, and this will give us 7 Newton. So it's going to give us something lower compared to what the sum will give to us. So this is what you ought to know about cases of parallel forces that are either acting in the same direction or in opposite direction. In this section, we are going to look at a case of two vectors acting perpendicularly. Now, this word perpendicularly comes from the word perpendicular, which means at right angle to one another, or simply put, at an angle of 90 degrees to one another. So perpendicular means at right angle or at 90 degrees. So when you are given a question, or you get to see two vectors acting like this, and then there's a box at this point, a box being formed at this point, just know that the angle formed here is 90 degrees. So when two vectors have an angle of 90 degrees between them, these vectors are said to act perpendicularly. So now when we have two vectors acting like this, the resultant, obviously in this case, we start from this origin and move outward like this. So we are going to have this as the resultant. So how do we calculate the resultant? It's very simple. Now when you close this up, we are going to have what we call a right angle triangle. And in solving right angle triangle, we apply this principle called Pythagoras theorem. But in this case, we are going to use the formula. So we are going to use what we call the Pythagoras formula in calculating the resultant magnitude. And then secondly, we are going to apply what we call trigonometry in getting the direction. So Pythagoras formula will help us to get the magnitude of the resultant. Then trigonometry will help us to get the direction of the resultant. So now this is arrow, which will be the magnitude. Then the direction is going to act from here to here. So this is going to be the direction. Let's say it is theta. So now how do we use Pythagoras formula? Remember, the Pythagoras formula tells us that the hypotenuse square is equal to the opposite square plus the adjacent square. So this is how we use the Pythagoras theorem. So we are simply going to apply this formula called the Pythagoras formula. Hypotenuse square is equal to opposite square plus adjacent square. But we can change this. We know this is arrow. Now this is, if this is Fy, the opposite side will also be fy. So remember, opposite sides in a rectangle or a square are equal. So if that's fy, it means this other side will also be fy. So this bottom part is fx. So that's good. So here we now have this as the hypotenuse is the resultant. So this is the hypotenuse. So this side facing the angle is the opposite. So we have this as the opposite. And then we have this side left as the adjacent. So we can now see that the hypotenuse, which is the resultant, is r square is equal to opposite is fy, or we can take it as fx plus adjacent, which is fy square. So this is what we finally have. So we have the resultant square. The square of the resultant is equal to the square of one side plus the square of the other side. So now in calculating for the trigonometry, we are simply going to apply the concept of tangent. And we know that the tangent of an angle, we know that the tangent is equal to the opposite over the adjacent. So this is the formula for tangent. Tangent is equal to opposite over adjacent. So now the tangent is the tangent of the angle. So we are going to take it as tan theta is equal to opposite. In this case, the opposite here is fy. That's fy. That's the force acting along the y-axis. Remember, in a given graph, the vertical side is the y, and then this horizontal side is the x. So we are simply saying the force of the vector acting along the y over adjacent. Now this is the adjacent here. Adjacent is fx. So that's going to give us fx. So now when you take tan to this other side, you're going to have theta. Now when tan gets to the other side, we have that tan inverse. So the inverse of tan. So we are going to have it as fy all over fx. So with this formula, you can calculate for the direction. So this will help us calculate the direction of the vector. While this over here from Pythagoras will help us to calculate the magnitude of the resultant. So this is what we need. So we are going to attempt this question. So let's say we have a force 3 Newton on this side, and then we have another one 4 Newton on this other side. So this is simply going to be our resultant arrow. So this is going to be arrow. So when we close this to get a triangle, if this side is 3 Newton, we are equally going to have side as 3 Newton. So now this is our direction. Our direction, now very important, I add this. Your direction is the angle between your resultant and this horizontal. So this horizontal. So don't ever measure your direction to this point. This is totally wrong. Your direction is the angle between your resultant and the horizontal. So this is your horizontal part, which is the x. So that's why we are using this particular angle and not the other way around. So now let's calculate the magnitude. Remember your formula, resultant square is equal to the fx square plus fy square. So that's what we have. So in this case, the resultant square is simply going to pick the fx, which is 4 square, plus then we have this as 3 square. Now arrow square is equal to 4 square, which is 16, plus 3 square, which is 9. Then we are going to add that up. Now 16 plus 9 is going to give us 25. So we are going to take this square to this other side, and when we do so, it's going to become a square root. So arrow is going to be the square root of 25. And finally, the resultant in magnitude is going to be 5 Newton. So what we have is just the value of the resultant in magnitude. So we are going to do so for the direction. So remember, we are going to use this formula here. So theta is equal to tan inverse of fy. Now what's our fy? This is our fy here, which is 3 Newton. So it's going to be 3 over, please, you have to know which side is the y and which side is the x. It's very, very important when you're calculating the angle. Now for the fx, this is clearly your fx. And just to add, this is fy. Fy is simply the vertical, like the standing position. And then fx is the line position. So this is going to be a 3 over 4. And then a 3 over 4 will give us 3 divided by 4 will give us 0.75. So when you take your calculators and you press tan inverse of 0.75, the value of this angle is going to be approximately 36.9 degrees. So this 36.9 degrees. Now then, something that is very, very important that you ought to know is that in some exams, you could be told to find it in northeast or northwest. Now, what we just did just now is that we got this part to be 36.9. 36.9. Now, it means that this other part, to get this other part, we are simply going to subtract it from 90. So 90, because this is a right angle and we said they are perpendicularly. So 90 minus 36.9 will give us what we call 53.1. So if you are being told to just leave your answer to the angle, to the resultant, to the horizontal rather, this is going to be answer. So this 36.9 to the horizontal. So let's just add it here to be more specific. So this to the horizontal. But in some cases, you could be told to leave your answer in northeast, northwest, or whatever. So now to northeast, this is going to be north 53.1 degree east. Because remember, this is between north and east. But in most exams, you'll just be told to leave your answer with that value to the horizontal, which is 36.9 degree to the horizontal. So don't forget, the answer clearly depends on what you are needed or what you are being asked. So any of them is typically correct. In this case, we are going to look at two vectors acting at angles other than 90 degrees to each other. We are simply looking at vectors that are acting at angles that are not 90 degrees to one another. So in the case of A, we could have forces or vectors that are acting between 0 to 90 degrees, but not at 90. And in this case, we call this kind of angles acute angles. So between 0 to 90 degrees, but not 90, we call them acute angles, or simply put, angles that are less than 90. So this is a case. Then in the second case, we could have it between 90 to 180, but not at 90 degrees. So angles greater than 90, but less than 180, we call them obtuse angles. So they could act in an obtuse manner. So these are cases we are going to look at in this section. So for such vectors acting at angles that are not 90 degrees to each other, either as acute angles or obtuse angles, we apply what we call the parallelogram's law of vector addition. Now, this is a very essential law every physics student should know. Now, what does this law state? It states that if two vectors, let's say F1 and F2, in either case F1 and F2. So if we have two vectors that are acting at a point, so this is the point they're acting on. This is the point they are acting on. So if we have two vectors acting at a point, and it's represented by the adjacent just simply means the close side of a parallelogram. Because if you close up this to form a shape, now we are going to have something like this. So we have a parallelogram. Same for this. So if we close up this, we're also going to have a parallelogram. So if we have two vectors, and these vectors are represented by the adjacent side of a parallelogram, means close side. So this side is close to this side. So by the adjacent side of a parallelogram, their resultant is the diagonal. We know the diagonal will run from one end to another, to an opposite end, a straight line. So this is a diagonal. The same thing for this case, we have a diagonal here. This diagonal will represent the resultant in both magnitude, again, because these are vectors, and direction. So you should be able to state this law. The parallelogram's law, again, states that when we have two vectors that are acting at a point, and they are represented by the adjacent side of a parallelogram, the resultant is simply the diagonal drawn from their common point in both magnitude and in direction. So we are going to look at how we apply parallelogram's law in solving or in addition of vectors. So we have two vectors, P in this case, and then Q. Remember, these vectors are represented by this adjacent side of a parallelogram. Then we are going to have a resultant, something around this point. So this resultant, which is diagonal. Now, if we just close this shape up, so if we close this up, we are going to have something similar to a parallelogram. So now this is a parallelogram. So this resultant arrow is the resultant in both magnitude and direction. So again, how do we calculate the magnitude and how do we calculate direction? So we use this formula here for calculating the resultant in magnitude. So this is derived from what we call the cosine rule. So it is derived from what we call the cosine rule. So for calculating, we have r square, which is the resultant, is equal to p square, which is one of the vector, plus q square, which is the other vector, minus 2pq. P and q are both vector, cos theta. Now the issue lies on this theta. What is this theta? Is it the one you were given, or is it something else? Now theta is simply the angle facing the resultant. So just to add, so theta here is the angle facing the resultant, angle opposite to the resultant. So take note of this, angle opposite to the resultant. And in most cases in exam, you won't be given this theta, but then I'll give you a simple way to calculate it. So when you are given the angle between both vectors, let's say in this case, we are given this angle here. To get this angle, because it's clearly this angle that is facing this resultant, so you can clearly see that this is the angle facing the resultant. To calculate for it, you simply use this formula, 180 minus that angle, let's say phi, that is between both resultant. So if, for example, we are given this, let's say we are given this to be 45 degree. So we have A and then we have B. So these are two vectors, and then we have our resultant here. So we close this up. This is going to be the theta we need. So this is the angle that is facing this resultant. So to calculate that, you just simply say 180 minus this angle here given, which is 45 degree. So obviously, this will give us 135 degrees. So this is the angle you need to solve. So take note, theta here in this formula is simply the angle that is opposite to the resultant. So if you are given, there will be no need for you to go through that process. So the second thing is, how do you calculate direction? In calculating direction, we use what we call sine rule. So we use cosine rule to get the magnitude, and then we use sine rule to get the direction. Now, how do we do that? You must first understand how to label a triangle. So if this is A, this side is going to be small a, so the side opposite to this angle will be small a. Then the side opposite to this angle, big B, we call it as small b. Then this side opposite here, we'll call this side small c. So now, how do we then calculate? It's a very simple task. So in sine rule, we simply use what we call side over sine of angle. So side over sine of angle. So that's how we do the calculation. So it's going to be this side. So a side, let's start with A. A is a side over the opposite angle, which is sine A, is going to be the other side B over sine B is going to be the last side C over sine C. So using this formula, we can calculate for the direction. Here is a question in which we have to find the resultant of the vectors. So here we have a vector of 10 Newton, and on this other hand, we have a vector of 12 Newton. And the angle between both vectors is 55 degrees. This means that the vectors are not acting parallel to one another, and also they are not acting perpendicularly to one another. So we are thinking of the case of two vectors that are acting at angles that are not 90 degrees to one another. And we are thinking of the application of the parallelogram's law of vector addition. So if we tend to close up this, we are going to have something similar to a parallelogram. So we are going to have something similar like this. So remember, we are going to take our resultant, which is a diagonal. So we have this to be the resultant, R. So now we need this angle, which is the angle facing the resultant. And this is simply going to be 180 minus 55. And this will give us, so we have 180 minus 55 degree. So this will give us 125 degree. So the angle here is 125 degrees. So this is the angle we need in solving. Remember, theta must be the angle facing or opposite to the resultant. So our formula is r square is equal to p square plus q square minus 2pq cos theta. So if this side is 10 Newton, this other opposite side will also be 10 Newton. So now we have r square, which is the resultant, is equal to p. Let's take one side as 10 square plus the other side as 12 square minus 2 times 10 times 12 cos the angle facing the resultant, which is 125 degree. So we have 10 square to be 100, then 12 square is 144 minus, so 2 times 10 times 12 will give us 240 and the value of cos 125 is a negative or minus 0.5736. So now we have 100 plus 144, and this will give us 244. Now, please, something very important. When you get to this case, add these two together and then work on this one as one unit or one entity. So don't ever try to add 100 plus 144, then subtract from 240. So work on these two separately, get your answer, and then work on everything here as one. So I'm simply saying work on 2 times 10 times 12 times cos 125 and arrive at your final answer. So in this case, minus 240 times minus 0.5736 will give us a plus 137.66. So then we are going to add up. Now 244 plus 137.66 will give us 381.658. So we are going to take this square to this side, making it a square root. So arrow is going to be the square root of this entire value, 381.658. And then when we take the square root of that number, arrow will give us a 19.53 Newton. So this is the value of the resultant in magnitude. But then we have to calculate the direction. So now what we are simply going to do is this. So we are going to take out this part. We are going to take out this part. I'm going to mark out now. We are going to take out this triangle. So we are going to take out just this part. So we are going to end up having something like this. So we are going to end up having something like this. So remember, this is 125. Now I told you that the direction must be the angle from this resultant to this horizontal. So that's theta. Then from calculation, we got this point to be 19.35 Newton. Then this is 10 Newton. And then this is 12 Newton, all from the question. So we now have this triangle. So what you do to get a direction, always cut out the triangle. So now when solving, remember we have to use sine rule. So a simple trick is that just pair or pick a side that is complete. Now if you look at this side has a complete angle, then pick the side that is facing the angle we need. So we need this theta, and theta is opposite to 10 Newton. So what we are simply going to do is that we are going to take this side, which is 19.35 over the sine of the angle, which is sine 125, is equal to the other side 10 over sine of the direction we need, which is theta. So we have this to be in 19.35. Now sine 125 will give us a 0.819 is equal to 10 over sine theta. So from here, we simply cross multiply. So when we cross multiply, we are going to have 19.35 times sine theta, and that will give us 19.35 sine theta. And then we have 0.819 here times 10. So 0.819 times 10 will give us an 8.19. So next thing, we are going to divide both sides by the coefficient of sine theta, meaning what is close to sine theta, which is 90.35. So we are going to use 90.35 to divide. So therefore, sine theta will be 8.19 over 19.35, and this will give us 0.419. So when we take sine to this side, we are going to have sine inverse. So here we are left with theta, which is direction, is equal to the sine inverse of 0.419. And the sine inverse of 0.419 is approximately 24.8 degrees. So this is the direction. So in magnitude, we have 19.35 Newton, and then in direction, we have a 24.8 degree. So this is the resultant in magnitude and in direction. So here is a practice question which reads, an object is acted upon by two forces, 5 Newton and 12 Newton. Calculate the resultant of two forces if A, the forces act perpendicular to each other. Secondly, calculate their resultant if the forces act at an angle of 40 degrees to each other. And lastly, calculate the resultant if the two forces act at an angle of 125 degrees to each other. So this practice question is for you. So do it to solve the question and then leave your answer in the comment section of this video, and I will respond to every comment. So that brings us to the end of this video lesson on the resolution of two vectors. If you have any question, comment or suggestion, do it to leave them in the comment section of this video. And also do it to like this video and also share this video lesson with your friends. And if you haven't subscribed to this channel, do it to click on the subscription button just beneath the video lesson so that you can always get notified whenever I release a new video. So till you get to see the next video, do have a wonderful time.